So this is technically the fourth video, and we're jumping to number 20. And on the test, I wrote this as a tip for you. On the test, it's going to say solve each equation by factoring, check your solution, but there are other ways of solving this equation. So we don't have to factor. What do I mean by we don't have to factor? Since there's only one x, you can isolate the x by getting rid of things. And how do you get rid of things? By doing the opposite. So right here we clearly see a 9 times x squared. So if I want to get rid of that multiplication of 9, I'm going to divide by 9. And what I do to one side, I do to the other. So I will have my new equation that reads x squared equals 64 over 9. Now, if it were 63 over 9, then yeah, 63 divided by 9 is 7, and that'd be awesome. But that's okay. Let's leave it like a fraction. 64 divided by 9 we can't do. We're going to leave it like a fraction. Now, we still need to get x by itself. The x has a square on it. If you want to get rid of that square, you want to do the opposite of a square, which is a square root. So let's apply a square root there and apply a square root there. What you do to one side, do to the other.
Why couldn't you apply it before you did the 9?
Because you want to isolate the x first, and you want to get rid of that 9 first, and then get rid of the square. Okay. Now, right here, I take the square root of both. Remember that when you do take the square root, now you're just going to have x, but you need to put a plus or minus in front of your answer. That's always the case. Whenever you apply a square root in an equation, you have to put a plus or minus in front of your answer. Now, the square root of 64 over 9, that could easily be done by splitting the square root to the top and splitting the square root to the bottom. And it's going to be 8 over 3, and that's it. So your answer is x equals plus or minus 8 over 3. Those are two answers right there, guys. Plus or minus 8 over 3. I mean, technically, you could say plus or minus 2 2/3 if you wanted to write it as a mixed fraction instead of an improper fraction. Let's move on to number 21. This is multiply and simplify. What does that mean? Just distribute and then afterwards combine like terms. Okay, so we're going to distribute one term at a time. As you can see, this is a binomial. There's two terms. So I'm going to just ignore, going to ignore the 4 for a little while, and I'm going to distribute the negative 7k. So negative 7k times negative 3k, that's positive 21k to the third. And then negative 7k times 2k, that's negative 14k to the second. And then negative 7k times negative 9, that's positive 63 with one single k. So I've distributed the negative 7k. Now what I'm going to do is distribute the other term. So let's move this over. Let's move this over, cover this up, and distribute the 4. So I want to distribute the 4 with a different color. So I want to go positive 4 times negative 3k squared. That's negative 12k squared. Now, instead of writing it right here, negative 12k squared, I might as well start lining them up. Let me write the negative 12k squared right below the other k squared. That way it'll be easier to combine them. So let me erase that. Now let me distribute the positive 4k, or the positive 4 times positive 2k. That's going to be a positive 8k, and I'm going to write that below the other 63k. And last but not least, we're going to go positive 4 times negative 9. That is negative 36. And now we're just going to combine the like terms. That's why I lined it up like this, so you could clearly see that the k squares are on top of each other. So negative 14 and negative 12, that is negative 26. And of course, we're talking about k squares. The 21k to the third, that's just going to come straight down. 21k to the third. The 63k and the 8k, that's 71k. Bring down the minus 36. And that's it. We are done. Oh yeah, by the way, this is a positive 71k. So this is your final answer right here in standard form. You should be able to see that on the multiple choice answers of your final exam. So I decided to line up the k squares on top of the k squares, the k's on top of the k's. That way they're easy to combine instead of looking for them over here, k squared with k squared. Let's move on. Number 22, the coordinate of the vertex of the graph of the function. Find the coordinate of the vertex. Okay, so we want the vertex. If we look at this in standard form, That's a standard form equation. If we are looking at it in standard form, then we need to use the formula to find the vertex x equals negative b over 2 times a. And as you could see, the a value is negative 2. The b value, the term with the x, is not there. There is no x term. There's an x squared, but there's no regular x. So if there is no regular x, if there is no b, that means that b is 0. And when you plug it in with parentheses, we said a was negative 2, right? So the a value is negative 2. The b value, there is no b value, so that would be 0, which means that your x value of your vertex is 0, because 0, whether it's positive or negative, divided by any number is still 0. So finding the vertex, that's what we're doing here. So your x value is 0. How do you find your y value once you already know your x? Plug it in. So take the 0, plug it in right there. It's really easy. 0 squared is 0. Negative 2 times 0 is 0. 0 minus 5 is that c value, negative 5. So the vertex is 0, negative 5. Is there another way of doing this? Yeah, you could have forced vertex form. What is vertex form? It's y equals a parentheses x minus h close parentheses squared plus k. So you would have to imagine that there's parentheses around the x. Now, because there's no other x's, I could actually do that. I could put parentheses around that x, and it would be x minus h, which there is no h, so that'd be a 0 there. The a value is negative 2, as you can see the a value above right here, and the k value out here is minus 5. So if you wanted to look at it in vertex form, which is y equals negative 2 parentheses x minus 0 squared plus k, your h value is 0, your k value is negative 5, so 0, negative 5 is your vertex. It's totally up to you if you want to look at it in standard form, or if you want to look at it in vertex form by putting parentheses around that single x. Let's go to number 23. Factor completely. Now, I like factoring quadratic trinomials that have the a value of 1, because whenever the a value is 1, you're supposed to attempt this setup, because b times b is the b squared, right? If there's no number in front, you set this up and simply think what times what is negative 30 or positive 36, that if I combine together is negative 12. If you're confused, make a list, right? How could you get 36? 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. That's about it. Those are all the possible ways of getting positive 36 when you multiply. Which pair of numbers combines together to give us the b value, which is negative 12? If you add 1 and 36, you're going to get 37, so that's not it. So the only ones that you combine together that'll give you a negative 12, well, 6 and 6, that gives you a positive 12. So you have the right number, you just have the wrong sign. So we have the right numbers, but we have the wrong signs. So let's change that to a negative 6 and a negative 6. See, a negative 6 and a negative 6, it does give you a positive 36 when you multiply, and it does give you that b value of negative 12 when you combine. So you're going to put a minus 6 right here and a minus 6 right there. That is factored. Now, I'm not sure if they leave it like this. They might present the answer as b minus 6 squared. Since it's the same exact binomial written twice, they might write it as that binomial b minus 6 in parentheses to the second power. And this is factored completely. I hope that makes sense to you guys. Let's move on to 24. Factoring completely. All right, so factoring. We always want to start out with the first type of factoring, first method of factoring that we learned. What was that first method of factoring? Anybody? What was the first type of factoring we learned? GCF. So we're going to pull out the GCF. What's the GCF?
7.
If we pull out a 7, what would be left on the inside?
B squared, 9.
B squared minus 9. Now, I want you guys to recognize that the inside is a quadratic, and technically it's a perfect square term here and a perfect square term there, so you could do the square roots and plug it into your answer format of v plus 3, v minus 3. Or you could think what we've always thought, that a quadratic trinomial, when there's no number in front, you could set it up like with a v and a v, because v times v is v squared. Now we want to think what times what is the last number that if we combine together is the middle number. And notice there is no middle number, right? There is no middle number. So what times what is negative 9 that if you combine together eliminates? A negative 3 and a positive 3. So your final answer is 7 times v minus 3, v plus 3. Of course, it could be plus 3, minus 3. It could be switched. That's fine. But that is your answer completely factored right there. Number 25. Determine whether the sequence is arithmetic, geometric, or neither. So maybe we need to do a quick little bit of notes right here. Let's jot down arithmetic. Now, arithmetic sequences or series have a common ratio. Arithmetic has a common difference. And usually we refer to that common difference as D. Now, geometric has a common ratio, which we usually refer to as just R. Okay? So arithmetic has a common difference. Geometric has a common ratio, right? So when you think of the word difference, what math operation do you think of? Difference. Subtraction, right? So if you go to the list over here, if you take 148 and subtract the number right before it, will it be the same as if I take 32 and subtract the number right before it, right? And the answer is no, it's not the same. It doesn't have a common difference, right? If I were to take 8 minus 32, I'll get negative 24. And over here, 32 take away 148 is not negative 24. It's something bigger. So there's definitely not a common difference. We need to find if there's a common ratio. Again, to find out whether there's a common difference or a common ratio, you have to pick a number and then either subtract the number right before it or divide by the number right before it. So we already did 8 take away 32 and we saw that there was no common difference. So now let me go 8 divided by 32. So that is a fraction, and that fraction could be reduced by 8. It will reduce down to 1/4. So far, I believe that my common ratio is 1/4. Now, if it is common, if that ratio exists with all of my numbers, then it is geometric, right? Now, if I try 32, this one divided by this one, 32 over 148, we could reduce 32 by 4. So if we reduce by 4, maybe I should do it in a different color. We get 8 on top, and on the bottom, if we reduce by 4, we'll get 37. So as you can see, that ratio is different than 1/4, so it is not common. It is not a common ratio. So it did not have a common difference. It did not have a common ratio. So what's the correct answer here? Neither, right? And the explanation is because it did not have a common difference or a common ratio. So right here, the correct answer is neither. This list is not geometric, it's not arithmetic, it's neither. Number 26, we need a graph again. And I believe there's another typo right here on 26. What's wrong with this problem, guys? There's no square on it. Ladies and gentlemen, please put the square right there on that problem. This is a parabola. We need that square there. My bad. Sorry about that. That's several mistakes I did on this practice final. Okay, guys. Number 26, you need that square, and it is a parabola, and it is in vertex form. So remember, vertex form is y equals a parentheses x minus h close parentheses squared plus k. So it is in vertex form, and why do we call it vertex form? Because when it's in this form, you could see the vertex. It's the h value and the k value. All right, the vertex is a coordinate hk, but on the notes I gave you, it tells you to remember to think opposite on h. So what is h really if we see a +3 right here? What's h? -3, that's right. -3. The k value is -5. You take it for what it is. So we know the vertex. That's the most important point. Let's go to the vertex. -3 on the x. -5 on the y. I'm sorry. -3 on the x, -5 on the y. That's down here. You draw that most important point. We draw the axis of symmetry right through it. And then we simply find more coordinates. Now, because this is the a value of 2, we can't use the pattern 1, 1, 2, 4, 3, 9 because the a value of 2 changes the outputs. So if you were to take the output of 1, multiply it by 2, you're going to get 2. 4 times 2, you're going to get 8. 9 times 2, you're going to get 18. So this is a new pattern. We need to use 1, not this guy, but 2. 2, not that, but 8. 3, not this, but 18. So 1, 2, 2, 8, 3, 18, and it is opening up. So from the vertex, you're going to go 1, 2, and put a dot right there. Then you're going to go back to the vertex, and you're going to go 2, 8 from the vertex. So 2, 1, 2, 3, 4, 5, 6, 7, 8 right there. And of course, the 3, 18, it's going to be off the graph. If I go 3 and 18, it's going to be off the graph, so I'm not going to worry about that. I am going to mirror these coordinates over to the other side, and I have my graph. It's slightly more narrow, more narrow than the regular U-shaped curve because that factor of 2 vertically stretched it. Anyhow, you will be able to identify it pretty easily on the final exam. They're going to give you 4 possible graphs. If you just know that your h value and your k value is -3, -5, you know it's here. And just based on the fact that your a value is positive, you know it's opening up. Moving on to the next page. Actually, no, let's not move on. We're going to stop this video right here, and we'll pick it up on the next video.